Yeah, hello to the TRS-80 Radio Shack Tandy community and the TRS-80 Discord and all the folks there that helped with this project. Happy Septandy 2025, and I'm happy to announce that the X-MEM 80 memory extension card for the Model I is finally a reality and reached its final PCB version. It's a 512 kilobytes page memory extension for the Model I. It is, in a sense, SuperMem compatible, right? So you can configure it here to either use supply 16 32 kilobyte pages in the upper 32 kilobyte address range, right, from 8000 to FFFF. So this is going to be paged, right, and it replaces the 32 kilobytes from the expansion interface if you have one, right? And then there is also the X-MEM 80 mode, which I wanted to have smaller pages, right? So basically, instead of replacing these upper 32 kilobytes with 16 pages here from this Alliance SRAM, you can also replace it with 32 16 kilobyte pages, and you can individually select the upper 16K page or the lower 16 kilobyte page, right? So it has two registers. One is for the memory range from 8000 to BFFF, right? So the lower 16 kilobytes in the upper 32 kilobyte address range, and then you can also replace independently the upper 16 kilobyte page from C000 to FFFF. In particular, I wanted this for MIDI 80, right, so that I can have MIDI song data in the upper 16 kilobytes and then have the program in the lower 16 kilobytes from 8000 on, right? And yeah, so let me demonstrate this card. So doesn't require any modifications to the Model 1 or to the expansion interface. So it's just expansion port plugin, right? So either directly using this edge connector here, which I recommend, or you can also use the normal cable connection, but you gotta use a very short cable, right? Because, I mean, there's a lot of activity on the bus. So let's plug this into the Model 1. So, of course, I mean, if you just boot it up like this without expansion interface connected, you see this is just a standard 16 kilobyte internal fully upgraded Model 1, right? So it has the memory up till 7 FFF, the lower 32 kilobytes or lower 16 kilobytes plus ROM, of course, fully populated, right? So, but now you can, the simplest use case is if you don't have an expansion interface and you just require more memory, right, say for your basic programs, all you got to do is plug in 5 volts, right? You see the power LED comes on, and then you see that now ROM basic has a little bit more memory. Oops, it's 3, right? Not none. 3. And now we have the full 48 kilobytes, right? So the upper 32 kilobytes, of course, now coming from X-MEM 80. Here configured in SuperMem mode, 32 kilobyte pages. Okay, but it gets more interesting if you have the expansion interface in the loop, right? So you have your disk controller and what have you. And let me do this. So fire up the extension interface. So what X-MEM does is it disables the extension interface, right? At least the memory, the 32 kilobytes which are installed in the expansion interface here are disabled and are coming from the page memory from the X-MEM 80. And of course some of the memory requests still have to go into the expansion interface, for example, for the disk controller, etc., right? So but as you see here, so expansion interface works as expected, and there is a memory SuperMem test program, right? So there's a little utility here which you gotta use to reset the X-MEM, right? So basically it sets it into page 0 mode, right, of the 16 0 to F 32 kilobyte pages as it is configured now, right, or 32 16 kilobyte pages as explained. So there's the memres utility that you should use whenever you use X-MEM. and the extended memory, because that way it sets the page registers to page 0, otherwise it's in an undefined state when it boots up. And then there is the memory test program here. By the way, I want to acknowledge Jens Günther, who pointed me to all this software and also helped with actually acquiring this software and putting it on disk images, right? So because I don't have a I'm not very versatile and good at doing these things, so thanks very much, Jens. So for example, he helped me with converting those to single density disk formats, because I don't have a disk doubler here and so on, right? And Jens Günther also wrote a TRS-80 emulator, which actually has SuperMem emulation already built in. Now George Phillips with TRS-80 GP is also picking that up. And he's also going to implement a X-MEM 80 emulation mode for the 16K pages, so that's great. And I also would like to acknowledge all the help and the incredible support, enthusiasm, and knowledge on the TRS-80 Discord. In particular, Kiwi since birth, the user there on the Discord, helped a lot with designing X-MEM, right, and coming up with the PLD equations to make that happen, as well as P. Burrell, or P. Burrell, I think, right? Thanks, Paul. That is all greatly appreciated. And then Jens Günther, of course, also for helping with pointing me to all the software. So you see here's a test program running now here. It reports now more than half a megabyte, right? 512 kilobytes plus the internal 48 kbs, I think. And so those are 34k dots. So the SuperMem worked a little bit different in that it was able to replace also the lower 32 kilobyte memory, but so the it's not being tested properly, but you can see that the extended memory, the upper 32 kilobyte pages are being tested, as well as that the tests of random bit patterns are succeeding here, right? So it's now reading the random data here from these banks for the stars. You see the different banks, and there are no read or write errors, so that works well. So this is one program you gotta try when you build your X-MEM 80, right? So I'll have the sources and the gabbers as well as the disk images on GitHub soon. I already created the X-MEM GitHub, but it's mostly currently it's still empty, so I'm still working on populating this, right? So yeah, so this is one program you want to try, the memory test program, right? And then there are a few programs that make use of the extended memory from the SuperMem days, basically. So one of those was written by Jens Günther and is a port to NEWDOS 80 here of the so-called SIDEKICK program, right? So first we gotta again reset X-MEM 80 so that we have a well-defined page number in the registers, and then we can launch SIDEKICK here for NEWDOS 80, which basically gives you 4 virtual Model 1 NEWDOS 80 machines, right? So you can now basically switch using shift, down arrow, and 0 to 3 between different machines, and you see the machine number here, machine 0, and then here we have machine 1, machine 2, and machine 3, and all of these machines keep their state, right? So you can, I don't know a lot about NEWDOS actually, so, but I can at least, you know, launch this Zeus assembler, disassembler for you in machine 3, for example, right? So I don't know how to operate it, so is there something like help? No. But let's go to machine 2, and there we can, for example, launch add TESM, right? So, oops, didn't find that. How's it called? It's called add TESM. Okay. There it is. And now you can switch between those two Zeus and Atasm conveniently, right? And we still have some more here, for example, Super Zap, because it's another utility. So yeah, a program written by Jens Günther. And I guess whenever you switch the computers, you get some characters into the keyboard buffer, so it's better to do a new line here basically, right? So some stuff is being inserted there. But yeah, it works, as you can tell, right? So that is SIDEKICK. There's another utility which I also got from Jens, which is the Hyperdrive. And this is basically a RAM disk for LDOS. That could also be quite useful, I think. Takes a bit to load. And now there's a program Hyperdrive on the disk. Let's reset the memory first again. I also put the mem test on this disk image, but here we are going to use Hyperdrive now to create drive 4. So if you just start it like this, it gives you now a RAM disk drive 4, and you can even create more RAM disks, 5, 6 and so on, as long as you have memory banks available, right? So it's now saying that it has the allocation map and the memory banks here from X-MEM or SuperMem, and it shows that it's using these banks for drive 4. So I can now work with the RAM disk as if it was a normal physical drive. And there it is, the Hyperdrive. For example, I can copy Hyperdrive itself from 0 to there, just as a test. And then I should also be able, of course, to launch it from drive 4. Seems that the power supply in my monitor starts to fail because it's doing this pumping sometimes. Now if we look into drive 4, we see that the directory is no longer empty and that we have the Hyperdrive command there. And if we invoke it one more time, then it's from 4 this time, then it will create yet another RAM drive, just as a test that this wasn't corrupted, right? It loaded much faster now, and then now we also have drive 5. So that's Hyperdrive. What else do we have? Yes, then there is an application called LeScript or LeScript, I don't know how to pronounce it, that also is able to make use of the 512 kilobytes that you now have for text. Without a memory extension, LeScript is a pretty big program. You can only write like 2 pages or so, right? But now you can write a whole book if you wanted to. So let's reset the memory and let's start LeScript or LeScript, I don't know how to pronounce it. LeScript takes a bit to load. Version 2.02, if you use like 1.7 or earlier, then the memory isn't reported correctly. But now you see that it's reporting 529, 920 bytes free. So and the byte count goes down, right? So it is able to make use of the extra memory. Good. So those are the main programs that we have. Then there's also like a diagnostic basic program from SuperMem, and I also still have to show you the X-MEM mode. So this is a basic program with SuperMem test program. So you gotta start the basic so that it doesn't get into the upper 32 kilobytes of RAM, right? So that this is free. Mem equals 32,768. And from there we can now load the SuperMem basic test program, which basically checks that the page register is working and also the bank switching for all the 16 banks, right? So SuperMem uses port 67 for the page numbers 0 to 15, right, to determine the page. Then we are poking into the highest memory location, also the page number, right? Then we are switching the page again, right? Go into all pages and read the bytes there. So we expect, because it's different pages now at that memory location, right, that to see 0 to 15. And also you can read back the page register from the same port 66 as well as 67. So 66 is only for X-MEM because I have two registers actually. 65 and 66 for the lower 16K page and the higher 16K page, and 67 writes to both basically, right, for the 32 as well as for the 16 kilobyte mode. So, but that's what we expect to see, right? So we can read the memory back for the different pages, right? Correct bytes in there, just the page number, and then also the page register read back using input I/O requests from port 66 and 67 is working. So let me now, so those were 32 kilobyte pages, SuperMem mode, right? Upper 32 kilobytes. And let me now configure the card for X-MEM mode, right? And so this is now 32 16 kilobyte pages and independent upper 16 kilobyte and lower 16 kilobyte page, right? And for this we have another test program which is memtest2. And now we have 32 16 kilobyte pages and we can swap independently between page 8000 till BFFFF and C0002FFFFF, right? So, and here we see now we have 31 pages, and this is a readback test as well, just in reverse order, and you should see this sequence of numbers basically confirming that page switching is working independently, both for the lower and higher 16 kilobyte pages as well as reading back over the page register ports. Okay, so this is the X-MEM test program and the SuperMem test program, both in BASIC. Now, the main motivation for me was actually to enable MIDI 80, right? To play back larger MIDI files. So you may know my MIDI sound card and MIDI interface card for the TRS-80. Exists both for the Model 1 and Model 3. And so if we plug that in now, for the first time we are able to play back complex MIDI by making use of the extended extra memory. So let me connect MIDI 80 and then show you the two programs that I have for playing back MIDI. And let's start in X-MEM modus with 16 kilobyte pages. So there is a song disk which is called Big Song 16, and this is demonstrating how to use the extra memory with the MIDI playback. And basically the loader program is now, I've split the big MIDI file using the Python converter on the PC into segments, right? 16 kilobyte segments that fit into the upper 16 kilobyte page from C000 to FFFF. And I'm now loading these segments. So this song consists of 4 16 kilobyte segments. So I'm entering 4 here, and now it's loading the first 16 kilobyte segments into the upper 16 kilobyte memory. So you'll see those are 4 segments now, so this is 4 times 16, so that would otherwise never fit into the memory, right? It's actually 5 times 16 kilobytes, so it's 80 kilobytes of song data for MIDI songs of that length and complexity. one really needs a memory extension. And now it's loading the last segment soon, and then it's going to start playback. And during playback, of course, when it reaches the end of one page, it switches to the next page. So playback speed is like 6, and you can now hear that it's starting to play some good old classic Berlin School crowd rock, Tangerine Dream. I actually have a YouTube video that only shows the playback of this song, right? So this plays for 4 or 5 minutes, but we can now play back arbitrary complex MIDI songs with the memory available basically on the TRS-80 Model I, realized by X-MEM. Okay, so much for this. And same thing basically, there's another demo disk that uses a 32 kilobyte page mode, so let me configure that back and show you that. So here the program was now running in the lower 16 kilobyte page, in the upper 32 kilobyte address range from 8000 on, right? And so I used the MIDI data in the upper 16 kilobyte bank and switched it there. But then in the other version, we are just running the program starting at the standard from 5400 hex in Model 1 memory, right? And we are now switching the whole 32 kilobyte pages for song data. So this is the Big Song 32 disk, which is using SuperMem pages of 32 kilobytes. And I also supply the loader assembly code, right? So you can have a look how to use SuperMem or X-MEM if you require 16 kilobyte pages for your own programs, right? And I should have reset the memory, right? And I did not, so let me do this again. There is always the memres utility on the disk first. So you have a well-defined state and start with page 0, memres, a loader, and so I put the jumper to the 32 kilobyte SuperMem position, and I mean let's only load 2 pages here, right? It's now loading the song data not starting at C000 but starting at 8000, and then you should hear the same song, of course. I'm probably going to make a few more song disks with these big MIDI songs, right? Or maybe even update this batch converter that the home computer guy wrote, right? Jürgen Wich. So that we can have really big and a lot of long MIDI songs. I played it back a little bit faster now using speed 5. Alright, so yeah, that's what I had to share. Like I said, the sources and the Gerbers and everything and the firmware for the GAL are going to be online soon, and next week the X-MEM PCBs for the Model 3 will arrive, and that requires a little bit different techniques. So this will require a CPU plug-in board basically. So I don't know yet if this is going to work, and obviously the PLD GAL equations are different because whereas for the Model 1 I could just selectively disable memory read and memory write basically to the extension interface, right, based on the address range that was being selected. Those lines are not directly available on the Z80 CPU or even on the Model 3 expansion interface, right? So it's not possible to create an expansion interface for the Model 3, an extended memory expansion for the Model 3 expansion interface, because the control bus signals are missing. So the only option really is to create a CPU plug-in board or something similar, right? and I went for the CPU plug-in board solution. So yeah, that's going to be delivered next week, and then I'll know soon if this route is going to work with the Model 3. Until then, guys, thanks for watching and thanks for your interest, and especially thank you very much again for your help and support and your incredible knowledge. So you're a great resource, and it's fun to develop these things together, both with members on the TRS-80 Discord as well as on the German Classic Computing board, right, where I met and found Jens Günther, who was an incredible resource of knowledge and very helpful guy. Thanks so much. Alright guys, until later, bye.